Here it is. P and Q are set up the same way as usual. P implies Q. We know that that's only true if P is true and Q is only false if P is true and Q is false. Well, that and not Q, that's false, 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 true. Because one of them is false in each of these cases. Here, each of these three cases. Not Q is false because Q is true. Here, P implies Q is false. Again, Q is true, so this is false. So we have false, 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 true. Here, we've got false, false, true, true, just depending on the value of P. So we want to show that if this is false, then we know this is true. And then if this is true, then this is also true, which is the case. So everything here is true. The argument is valid. This is a tautology. This pattern of reasoning is called modus tollens, or the law of contraposition, or indirect reasoning. Another example, I'll buy a car or I'll take a vacation. I won't buy a car, therefore I'll take a vacation. We let P be I'll buy a car and Q be I'll take a vacation. I did something a little backwards here. I'm just going to make this easier on myself by changing this to I won't take a vacation. Change that to I won't take a vacation, and this to I won't buy a car. Or I'll buy a car. There we go. It doesn't matter, it works either way. So I'm just doing that because I changed P and Q around in a lot of different places here. Okay, so I'll buy a car or I'll take a vacation. That's P or Q. I won't take a vacation. That's not Q. And I'll buy a car. That's P. So our statement, our final statement is P or Q and not P implies Q. Therefore, so we set this up. Here is our or statement, P or Q. Well, that's true unless they're both false. Not P, true, true, false, false, true, true. So P or Q and not P is false, false, true, false. Well then, when not P is okay, and then we're saying that or implies Q. Well, P or Q and not P is false. Q is true, so that's true. P, I mean, if this is false, then this is automatically true. The only one we have to worry about is if this one right here is true, because that's the one that's true. Everything else in here is false, but it's also true here, so it's good. True, 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 true. That's a tautology. The argument is valid. This form of argument is true by the law of disjunctive syllogism. Remember, disjunctive, disjunction, that's where we have that or statement. And here is our last one. If it squeaks, then I need WD-40. If I need WD-40, then I must go to the hardware store. Therefore, if it squeaks, then I must go to the hardware store. Our solution, we start off by labeling each of these phrases. P is it squeaks. Q is I need WD-40. R is I must go to the hardware store. So our argument is P implies Q, Q implies R, therefore P implies R. And the statement of this argument is if P then Q and if Q then R implies if P then R. So on the next page, we'll look at the truth table. And of course, this has 8 lines now. There's a lot to it. But if we walk through it, we can see that our conclusion, that our statement is ultimately a tautology. Everywhere it's correct. It's true. The argument is valid. This pattern of argument is called reasoning by transitivity, or the law of hypothetical syllogism.